Okay, I think we're live down here. Awesome. Yeah, good. We'll let people roll in here for a couple minutes.
Cool. I'm
My
putting out some tweets
my
as
first
well.
time hosting it myself on Restream, so I'm just checking to see that all went smoothly. It looks like we're off to a good start so far, so give myself a nice pat on the back for that.
Good job, Matt. High five.
Yeah, thank you. Yeah. Just gonna go quote from my account as well. Yeah, for those of you that are joining in right now, please give us a retweet. Let your friends know that we're starting here. We're gonna kick things off in just a minute, but we'll give us an opportunity for more of our friends to join us and make sure that they don't miss the start of it. It is being recorded as well, so if you know people that missed it, make sure they get the recording. Okay. Awesome. Yeah, I can see people flooding in here, so I think let's get started then. You guys know me. Today we have two very special guests on the podcast. I will let each of them introduce themselves. You know what it is. This is Spicy Takes. I don't even know what episode we're on, but here we are week after week. And we had our partnership announced this week with both parties that are in the room today. So it's a super exciting day for us to get to know them better as a community and share some of the exciting things that we have coming up. So, Stefan, do you want to get us started on the Acc Ventures side and introduce yourself?
Sure thing. Yeah, great to be here. Thanks to the Spicenet team for coordinating this. As Matt said, I work for ACC Ventures doing podcast hosting and marketing. I guess I should say my name. My name is Steven. Currently based on the west coast of the United States, and been in the crypto space or blockchain, Web3, so many different words for it since 2017 when a friend told me about this thing called Bitcoin. I bought some, felt like a scam, but all these years later, I've come to understand it much better, and happy to be here with two very bright minds that I've had the pleasure of speaking to both separately. So I'll throw it over to you, Gregory.
Hey, I'm Grigore Rosu. I'm the CEO and founder of Pi2. Previously, I founded Runtime Verification, which is now a major company doing security auditing based on formal verification, which is the highest level of assurance for correctness. And prior to that, I was a research scientist at NASA, working on the exact same field, making sure that programs do what they are supposed to do. I'm also a professor of computer science at the University of Illinois Urbana-Champaign, where I teach programming languages and concurrency.
Super cool. I didn't know that about you with the NASA background. I mean, is that how did that transition work from NASA into what you're doing now?
Almost very smooth transition, almost unbelievably easy transition, because it's all about correctness in the end and mathematical rigor. And we just transitioned from applying that to spacecraft and mission critical software to smart contracts and protocols on the blockchain, which are also in desperate need of correctness and security.
Yeah, absolutely. I mean, that's I have an engineering background as well. Yours is definitely more impressive than mine. It's really cool to see that transition. You went from taking humans to the moon to taking coins to the moon. So if you want to tell us as well, like elevator pitch Pi2 for people that don't know what it is yet here.
Well, the name Pi2 comes from proof of proof, specifically from cryptographic proof of mathematical proof, which is a universal approach to verifiable computing. So we have a way to bring all programming languages and all virtual machines, all computational models to Web3. That's one thing. And the other, which is perhaps even more important here, is the infinite scalability nature of our network. So we have the fastest decentralized network ever, both implemented and in theory. We have unlimited TPS, theoretically speaking. It's only limited by the internet, your internet, how good your internet is. So the protocol, we have a consensus protocol, which is called weak consensus, which can be as fast as the resources that we put into it, unlimited anymore by the constraints of blockchains.
Wow. So it's not technically a blockchain, right?
No, it's more powerful than a blockchain. Blockchains can be deployed on top of this infrastructure. It's a more fundamental infrastructure than blockchains. It is not constrained by the total order of transactions that we see in blockchains. And at the same time, everything is verifiable, correctness, because in our world, that is not negotiable. Correctness, security, they are absolutely required and not negotiable. And also all programming languages. So whenever I say anything about performance, I take for granted that everything is correct by construction and we can use any programming languages and computational paradigms.
Oh, that's amazing. I mean, I'm definitely looking forward to diving in deeper here. But I think Stephen had some thoughts that he wanted to kick us off with here today. So I'll pass it over him to do so.
Yeah, thanks, Matt. I'm not a engineer like the two of you. I guess I do produce audio engineer, but like I already mentioned, you guys are both bright-minded individuals, and I'm really happy to kind of bring you together. Not that it was my doing, but happy to be here facilitating this conversation. So kind of what I like about kind of what we have going on here today is, from what I've learned in our conversations between each of us individually, is that kind of on Matt's side, if speed is kind of so, or I'll flip it around to Grigore, like if speed is useless without proof, and proof is useless if it hurts a user design, and today is kind of making about both of those feel instant. And Matt, you've talked a lot about with Spicenet how it's the whole idea is to make things really invisible. And Grigore, Matt, you just clarified that it's not even a blockchain. So you guys have made the blockchain invisible such that you've made it irrelevant. And we were just talking yesterday how solving problems becomes so key when you totally forget about what the initial problem was to begin with. So Matt, you mentioned that Spicenet and Pi Squared have come together and announced a formal partnership. So first, I'll give it to you, Matt. What do you see Pi Squared coming in to help to facilitate? Basically, what's the question, or the question I'm asking is, what do Spicenet and Pi Squared solve together that neither could do alone?
Yeah, definitely. So we have two products, right? And the thesis behind the first one is, the problem that we see is people having to build where they think they can get access to users and not build where they actually have the best tech to support their product. Now, I think Pi Squared is just a perfect example of how you might not always want to host something on Ethereum, right? Like right now, Ethereum has all these users, it has the most developers and stuff, but like there are always new technologies being built, and like ones like Pi Squared are 10 times more impressive. Or I mean, if you're talking infinite speed, it's like infinite times more impressive if the metric is speed, right? And if we don't have the ability to distribute that to users and bring it to where the users are, to where the capital is, then we risk some of that great innovation going to waste. And that's really the main thing we wanted to solve with our first product. And I think it's just a perfect fit with Pi Squared because they're building something that is such a key competitive advantage to be building on top of them, that we want to make sure they're able to get that distribution to the users. So that's really our goal here.
Yeah,
Cool. And
wonderful.
Grigore, what about you?
Yeah, if I may add, so as you said initially, Stephen, let's not forget what the main problem that we are trying to solve in this space was. We want decentralized, secure, verifiable settlement. And blockchains are one way to achieve that. The problem that we encounter with blockchains is the scalability. They do not scale, they are slow. Some of them are faster, but overall, blockchains enforce a certain discipline which requires all the validators to talk to each other continuously, and that makes it very, very slow. Um, and the reason I really like this partnership is so Spicenet tries to bring, yes, all the users, the applications to the users. That means going across different blockchains, doing trades that happen across different blockchains. How do you verify all those? How do you settle all those? You settle portions, fragments of it on one chain, fragments on another chain, but you don't have a unified view of what's going on. And this was also one of our problems at Pi Squared. We didn't have any meaningful and universal way to connect all the different chains, all the different applications, all the different things that we have proofs for. That's why we wanted to have proof of proof first place. It doesn't matter where your thing comes from as far as you have a proof. We can give you a proof that you have a proof. And now it becomes universal. We can put them all in one big pool of things which are true. Things like a Wikipedia, where every single fact comes with a proof, is verifiable. And now I don't care where that fact is stored because I know it's true because I have a proof for it. So same when I saw the Spicenet products, I was so excited because that's exactly what we need to integrate with. That's one of the best possible applications that we can integrate with Pi Squared, because now we can take the different proofs, the different trades happening on different chains in different ecosystems, and put them all together. Because in our world, they all become mathematical proofs. And by the way, mathematical proofs compose by design. That's how mathematics was invented and evolved through composability, right? You can use Pythagoras' theorem when you build a bridge, or when you build a building, or when you build a pyramid, right? So compositionally, it would be artificial to say that, well, Pythagoras' theorem doesn't integrate well with my blueprint of the pyramid, right? So same here. We have the universal framework where we can bring various truths together, and the truth is something that comes with a proof, a claim. We call them claims, actually, which could be a trade, depositing liquidity in a protocol, withdrawing liquidity maybe on a different chain from the same protocol that can go cross chains. So all these are possible and correct by construction on the Pi Squared infrastructure. And the Spicenet products seemed like just a marriage made in heaven with Pi Squared. I was super excited when I saw the value prop and the mission of Spicenet.
Yeah, just yesterday I was having another podcast shoot with you, Grigore, and you were mentioning, I asked you deliberately, what are the paths to success? You know, how is Pi Squared going to win? And you clarified, you know, a few things, importance of having foundation. And the second thing I believe you mentioned was integrating deeply with basically, you know, products, companies, people that will have very far reach. And that sounds exactly like what we're, you know, talking about today. Am I
Perfect.
following the train of
Yes.
thought?
Yes, this is a perfect example, perfect integration of that kind. Yes, because our technology, our infrastructure is so general that the risk is to not prioritize and get lost in the universe of possibilities. So that's why we are very interested in integrations like this one with Spicenet, because we capture a certain domain and bring it to, again, let's not forget the big picture, which is verifiable settlement, but also the speed of light and across various languages, which is just, as I said, marriage made in heaven with
Yeah,
Spicenet.
there's one thing that I like to talk about as a case study, and I'm wondering if this is kind of something you guys think about. I'm sure it is, Grigore, is like for algorithmic traders, right? Their edge is basically how fast can they execute their strategy, right? Because like let's
Yes.
say it's an arbitrage strategy, the price differential is only available until somebody closes it, right? So basically the first person to execute on the strategy, the fastest person to execute on it, is the one that gets paid.
Yes.
I'm assuming this is something you guys are kind of thinking about as like a market that could definitely take advantage of what you guys have built because they'll have that infinitely scalable speed. It's something that we're thinking about as well, with like allowing people to collateralize ahead of time from whatever chain they're on. So then when it does come time to execute, like they're ready to execute on whatever chain they need to execute on without having the latency of the source chain that they came from be part of it.
And of bridging.
Yes, exactly. Yeah. Bridging, escrowing, all of this stuff. They can basically do it ahead of time if they know, like, if you're an algo trader, you know that you're going to want to execute very quickly, right? So
Yes.
that's something that I think about being really powerful with what we have here is like people could basically deposit into escrow ahead of time, knowing that they're going to want the quickest settlement possible. And then since pi squared is able to basically beat anybody else in terms of their time to execute, like their quickest path for their algo will default to pi squared in a lot of cases if it has like whatever the liquidity
If
or the asset available.
if all the assets were on pi square's network, our FastSet network, then yes, that would be all instantaneous, and you could do hundreds of thousands of such trades per second. We reached 250,000 TPS without even doing a lot of optimizations, and we hope to reach 1 million TPS by mainnet, which will be early mid next year. But the problem is that assets are all over, and I'm sure that you face exactly the same problem, Matt. That you may deposit Ethereum, ETH on Ethereum, and you may want now to do an arbitrage trade on Base, let's say, right? If you happen to have the Ethereum on Base, then great, you can do it. But if you have to bridge the Ethereum, the ETH from Ethereum to Base, right? That's expensive, and then what you want is to have like a unified view of your liquidity. The liquidity may be spread on different chains in different protocols, but if you have a unified view, like a bookkeeping, you can keep. The point is that you can keep this bookkeeping on FastSet on the Pi Square network. All right, and you have a unified view, but you know that the actual ETH may be stored on different chains at different moments in time. But with this unified view, you can now take advantage of such an opportunity that an arbitrage can be done, let's say, on Base, because there is ETH on Base that is not being used for anything else. And now you just have to move, in some sense, the ETH from one pocket to another on FastSet from Ethereum to Base without doing the actual bridging, which is expensive. So we actually have a product exactly for this purpose. We call it OmniSet. So our network is not a chain, is a set. It's a new category of infra for Web3. Set because there is no total order between claims. And through OmniSet, you have this unified view of your liquidity on different chains, L1s or L2s. And now you can, through an API programmatically, do trades without having to bridge, unless it is absolutely necessary. If you don't have any ETH on Base and you really must do a trade, of course, you cannot do it unless you move that ETH to Base. But most likely in a complex organic system, you will have liquidity stored on different chains available for different opportunities for different clients of the protocol. So that is the hope. But to get back to the original question, yes, if all assets were available on FastSet, then everything could be instantaneous and as fast as in the Web2 universe. But unfortunately, assets are spread all over, or fortunately, they are spread on different chains. And now we have to be smart to do the right bookkeeping, verifiable bookkeeping, and still get end-to-end verifiable trades and verifiable settlement for them.
Yeah. I'm glad you brought up OmniSet because hearing about OmniSet and understanding that, Matt, I mean, it sounds like that has direct correlation with Spice Flow, as I come to understand, in terms of connecting across chains without forcing users and developers to hop chains manually. So if you want to share some more about Spice Flow and how that might kind of relate or be able to be improved by what Grigore is explaining with the OmniSet.
Yeah, for sure. So Yeah, SpiceFlow, I mean, will have readily available liquidity sitting on chains, ready to basically deploy it on the user's behalf. The user can use their wallet on like Ethereum, but if they, want to execute on base chain, yeah, essentially we can have our liquidity that's sitting there. It deploys on behalf of the user, and then we can consume the user's escrow only once we've returned the results that they want to the user. So this allows them to basically self-custody their assets and execute through us by like delegating execution for a brief second. This uses EIP 7702, which is something that you're familiar with, Grigore?
A little bit, but please remind us.
Yeah, so 7702 is basically like a delegate a contract on Ethereum. So you can basically sign to delegate execution to another party for whatever the terms of that contract
Right.
are. And
So now you can do the thing off chain basically. But you are
yeah,
trusted. You become trusted. You need to bring a proof, right, of that.
yeah, like I mean essentially the person is signing for all of the actions that is going to happen on the other chain that Spicenet is going to carry out for them.
Interesting, very interesting. Because I think we can eliminate that now with Pi Squared, because we can do all these actions, everything that Spicenet does behind the Ethereum, or not behind, but off Ethereum, all those can be now registered and settled as verifiable actions on FastSet, that bookkeeping that I was talking about. And then you can compose end to end the fact that I moved one ETH from Ethereum to base, and I took advantage of this arbitrage. Now it's an end to end proof that this happened without having to trust anybody. I mean, I trust Spicenet, but if we can eliminate trust completely, that's even better, right?
Yeah, absolutely. I mean, yeah, that's the point as well. What we're building and why we made it like atomic. So it either like succeeds and you get the result you want, or it fails and you get your assets back. But yeah, I mean, it's interesting to talk because like we're trying to solve some of the same problems here, and it's always interesting to see like how other people are approaching it, right? And it makes it obvious that it is a problem that everyone needs solved, right? When you see
Yes.
various solutions, and I always believe it's better to like look at what other people are
And
doing.
also, I think we both need liquidity pools on
Correct.
different chains,
Yeah.
right? In order to minimize this actual physical transfer or bridging of assets from one place to another. So at the minimum, we can unify these liquidity pools, and that will make everything, more to be
More
faster.
liquid.
Exactly.
Yeah.
So I guess my question, and I'll speak on behalf of some of the audience members too, because I'm sure that many people have this kind of question too. So Matt, and in our previous conversation, it's clear that Spicenet is creating its very own layer one. So I guess I really want to kind of understand. I may have missed it, so forgive me. But where does Spicenet route, and like where does Pi Squared prove settle? Like, could you sketch the handoff for us to really understand the integration here?
Yeah, so I mean, essentially, we can enable people to place transactions to the OmniSet through us. So we would be like an actor that's showing up to the OmniSet and placing a transaction to it. It's just about connecting people that don't have access to place a transaction directly to it themselves. That's kind of the first thing, and then the other thing goes the other way is like integrating with venues that we have access to, and basically allowing any Pi Squared application within the OmniSet to tap into the liquidities, the yields, whatever it may be from any of the other venues that exist in the space that they could take advantage of to provide better outcomes to their users.
Yeah, precisely. Also, any claim that is settled on the Pi Square network, on the FastSet network, in particular, a particular trade somewhere, right? You get now a proof, a membership proof that it happened. And now the Spicenet contracts can accept such proofs, for example, and release liquidity for example, to their users because they did what they said they would do, and that is verifiable. And I mean, a proof has been generated, and the claim has been settled, and you get a proof of settlement, which is much, much, much shorter and more compact. Now you asked about proofs, where the proofs live, Stephen. So there are all kinds of proofs. On some chains, you have proofs by re-execution. On others, you have proofs using ZK technology. On others, you have proofs using stateless, for example, execution. So PySquare does not commit to any particular proving technology. So it makes a clear distinction between verifiers and validators. Verifiers are in charge of verifying proofs. So each application is free to choose whatever counts as a proof for them. For example, ZK Sync will say that a proof is a zero-knowledge proof of a certain computation. Right? Base will say that a proof is the lack of a fraud proof in a certain time window. Okay, so or Ethereum now can say a proof is a stateless witness that of the computation, right? So now verifiers verify these proofs, and once they verify the proof, when there's a quorum of verifiers verifying the proof, their aggregated signature will serve as a proof of the claim that is being made, and that is then sent to the validators. Validators will check the proofs of the validators, verifiers, remember, proof of proof. They will check the proofs of the verifiers before they settle everything. And once they settle, they will issue a signature, which is also a proof of settlement, the membership proof. And now that can be used however everybody wants in the Web 2 or Web 3 world. In particular, smart contracts, like Spicenet smart contracts, for example, can use that proof as a proof of claims of interest to them. Like a trade happened on some other chain, or a deposit happened, or a withdrawal happened. Right? So all this can be settled. So I agree with Matt. There is a bidirectional integration here. Right? So Spicenet can actually generate claims to Omniset, or trades or transactions through Omniset. And at the same time, proofs of different actions, transfers, transactions, claims of any kind happening on FastSet can be taken to Spicenet contracts, which then can do things in a verifiable way. You see, so we can eliminate trust here. So instead of having to trust Spicenet, you have actually a proof that whatever Spicenet did was correct, and it's all verifiable and settled.
So just to go back to something you said earlier, because I thought it was interesting. You said like math by nature is composable, right?
Yes. Yes.
All of these different proofs of all of these different kinds are a form of math.
In the end, yes. Mm-hmm.
So then adding these proofs together into a single proof is basically possible no matter what the proof type is, because
Exactly.
by nature math is composable.
Exactly. Yes.
Dude, you
And
should
math
be
does
like
that
you should
for
be like a
free.
math professor. Like
I mean, math does that for free to us. If we reduce computation to mathematical reasoning, unfortunately, what we see in many attempts is all these desperate, interoperability hard pushes. For example, you see a protocol executing something on an Ethereum based or EVM based chain, right? Then a bridge taking that to a Solana, let's say. Then from there, some other bridge taking it to Base, and then from there to Algorand, let's say, right? And now the actual end-to-end claim or mathematical theorem, okay, is split in pieces all over, and some of these need to be trusted because there are things happening off chains. Okay, it's very hard now to have an end-to-end proof that the whole thing is correct. But if you reduce everything to mathematics, then mathematical proofs compose, and now you have an end-to-end proof that yes, this happened. All these things that I said in words very complicatedly, all this happened, and it's verifiable and irrefutable and settled.
Yeah. Well said.
Yeah, like I said, these two guys, for anyone in the audience, are both very intelligent, to say the very least. And Matt, I'm not sure you may have known this, but Grigore is a professor, and you teach computer science, right?
Yes, at University of Illinois. Yeah, University of Illinois Urbana-Champaign. Yeah,
Oh, that's hilarious.
I teach computer science and programming languages and concurrency.
Well, that's good because yeah, I didn't know that, and the thought in my head was just, damn, this guy would be good at teaching this. So that's cool.
Yeah, that's one thing that I've really enjoyed about chatting with Grigore is, he clearly has the experience of speaking to students and kind of understanding what level they're at, what sort of, understanding or knowledge gaps he could, come in and fill in. And, I should be paying Grigore for having him on the ACC podcast because I'm just, doing my best to kind of be a sponge here and learn. But what about you, Matt?
In fact, this semantic framework, the K framework that allows us to reduce computation to mathematical proof, that has been developed over many, many years. I proposed it back in 2001 when I was still at NASA, and then it was improved ever since by many generations of students at university. Okay, the only part which was missing was the performance of settling these verifiably on decentralized networks. And we tried blockchains, and they were too slow. So then we had to come up with the new protocol FastSet, which has solved the scalability problem as well. Mathematics is not only precise but also very fast. Once you understand exactly what you do, then it's very fast. It's very fast to settle a mathematical proof, a mathematical fact, once you know it is true.
So Gregory, your video feed has stopped on us there. I'm not sure if it's an internet thing or what's going on, but just wanted to bring that to your attention in case you're noticing it. But no problem. I just wanted to mention that in the comments, somebody talking about the optimization that you guys have done to reach 250,000 transfers per second is pretty crazy. And you mentioned how by mainnet. Q2 of next year, you guys are aiming for 1 million. And it just kind of hit me like, oh, some of these people coming from the Spicenet corner may not actually understand kind of really basically what pi squared is, because it's like, wait, what do you mean like pi squared isn't blockchain? Like, it's honestly, it took me a second to kind of like understand it. But yeah, basically like the ideas I've come to learn, I'll step in here, Gregory, and explain it to you, and you can provide any quick clarification. But yeah, the whole concept is, Bitcoin is kind of every claim needs to come in and be verified one at a time to make sure that there's no double spending. So that if I have $1 in my wallet and I send the whole dollar to Matt, and then I have no dollars left, so I couldn't send it to Gregory. And up until now, the concept has been, well, one transaction at a time. Therefore, we know $1 is out, so the other dollar that is not there can't leave again. But through the FastSet, you guys have basically figured out that using proofs of proofs, that all of these claims can be verified independently, so therefore can be just uncapped in terms of speed. There is no one at a time kind of process that we've seen so far. All of these can happen in parallel concurrently and can be I guess scaled by just adding more validators. So I just wanted to step in a little bit there and explain how that's even possible, and even understanding like, what do you mean this isn't blockchain? Because blockchain was kind of the door, metaphorically speaking, but now we're learning how this can really be expanded and do much more than we've seen in the space so far.
Yeah. So can you hear me? I cannot fix the camera. I'm so sorry, but if you can hear me, we can continue. Then I'll try to refresh everything.
We can hear you crispy clear. So
yeah,
good, perfect. So indeed, that's how I also got into this field, through blockchains. When I discovered Bitcoin, I was so excited. I just couldn't believe it. I read the paper, I did the transaction, and I said, it's unbelievable. It happened. It's a decentralized peer-to-peer transfer system. It's so unbelievable. No intermediary, no nobody. I was so excited. But my excitement then slowly decreased when I realized how slow it was. And that was the belief back in 2000s, early 2000s, that in order to avoid double spending, not only Satoshi Nakamoto's, but many other cryptographers, great cryptographers, top cryptographers, believe that the way to avoid double spending, they acknowledged that double spending was the biggest problem that had to be solved. And in order to solve double spending, we need to totally order the transactions to form a chain. That's what Satoshi Nakamoto proposed in the abstract of his paper, and then several times in the introduction and everywhere. And yes, a total order on the entire universe gives a total order for each client, right? And now, if you have a total order for each client, you cannot double spend. Okay, if all your transactions are totally ordered, then you cannot double spend. That's what you want. You don't want a total order on the entire universe. But back then, we didn't know how to do that. Nobody knew how to do that. And you gave me credit. Thank you, Stephen. But this was really not our invention. So 6 years ago, an academic group at EPFL in Switzerland, the idea came from a university. They demonstrated for the first time that you do not need a total order in order to avoid double spending. All you need is validators to keep track of the total order for each client individually. But the transactions or the actions by different clients can be interleaved arbitrarily by different validators. And they came up with a concept that today we call strong eventual consistency. Blockchains implement a much stronger concept called strong consistency, which was proposed by Leslie Lamport in the 80s. So in some sense, blockchains implement a very, very old concept in distributed systems. And these professors, this academic group at EPFL, they realized that there is a more general concept, a more powerful concept called strong eventual consistency, which is sufficient to avoid double spending. Okay, in layman terms, what that means really is that on blockchains, if you freeze the entire universe at any given moment, every single node has exactly the same state. In this new approach, if you freeze the entire universe, every single validator may have a different state. But that's okay, because the guarantee is that when all the transactions clear, everybody will again reach the same state. So everything is still consistent, but eventually, not strongly, not right now. And when I saw that paper 6 years ago, I was completely, amazed. That was my wow moment, my eureka moment. When I realized that is possible, I said, what? Then why do we continue to do things as we do them with blockchains? Maybe it's time to go in a different directions now. At least with respect to payments. We know that payments now can be done differently, can be done at the speed of light, truly concurrently. And studying concurrency and teaching concurrency, for me, that was like a huge revelation. I said, this is it. This is worth spending my life on, because this is so transformative, even just with payments. Okay, but then we realize that, wait a minute, these don't have to be just payments. Can be any computations, anything that I can have a proof that they are true. And now think about mathematics again. Imagine all the mathematical results that we have. Pythagoras theorem, Fermat's theorem, Lagrange theorem. There are so many theorems, right? Should we prove them in order? That would be stupid, right? So we can actually prove them in completely different orders as far as each of them has a proof. Now we can settle them. Get back to that Wikipedia metaphor. So everything can go on Wikipedia in parallel if they have proofs. They can be settled once and for all once they have proofs. And payments are just such particular claims. The proofs are actually ridiculously simple, just your signature. That's the proof of a transfer, of a payment. But the idea is much more general. And that was our breakthrough when we realized that we can put together this amazing idea by these Swiss professors, a TPFL for payments, and proof of proof. Basically, any claim that comes with any proof. Now we can actually put all this together into a uniform protocol that is driven just by mathematical absolute correctness. And settlement is not an issue anymore. Settlement can be done completely. We call this embarrassing parallelism. It may sound negative, embarrassingly parallel, but it's actually super positive in the world of concurrency. When you hear that something is embarrassingly parallel, that means that every single thing can be done completely independently and in parallel with everything else. That's the ideal that we aim for. So that's what it is. FastSet now is an embarrassingly parallel settlement, verifiable settlement layer. And it doesn't have to have a total order. If you need a total order in some applications, and many DeFi applications requires total order, like trading applications, because every single trade enforces a total order or affects the price, right? So the order is super important. Then those applications can implement their own mechanism to have a total order, which can be chronological or based on fees or based on maybe even MEV, if that's what they choose. But it is their business. It is not the business of the entire universe to give them total order. They should totally order themselves. Okay? So that's the philosophy.
Awesome stuff. So as we are approaching, unfortunately, close, we're not there quite yet. And I really just kind of want to step aside here just for a moment. I was, invited to come on this space, but I think just Matt and Grigore, I want to give you guys a chance to just ask questions at each other. I'm not sure if I really needed to be here, but again, it's been an honor and a pleasure to be here with you guys. But Matt, I want to throw it over to you, give a chance to ask Grigore anything, and then vice versa. Just kind of see you guys riff off each other, and use this for the most.
God, I think I could probably spend a couple hours talking to Grigor here, because
Well, we will eventually.
yeah, it's something we need to sit down probably in person one time and just have my mind blown for a while. But I mean, yeah, there was so much in what you said there that I want to ask more questions about. I guess one quick one, because I know we're trying to wrap it up, but like, in terms of saying, like, the world doesn't have to have any business in your ordering. You can design that ordering within your own application. This means like how would somebody go about designing their own ordering? If is it like isolated ordering, where basically like their transactions have to be ordered relative to one another, but it doesn't concern anybody else in the network of transactions?
Yes. So we have a whole section in our white paper describing this, but at a very high level, the idea is to maintain the mempool inside the application. Imagine like you have a set of transaction or trade intents. I want to swap one Bitcoin for ETH, for example. That's an intent. I send it to the application, and the application decides its own clock. Let's say every 1 second, okay, it will have like a clearing of all the trades. All right, so now the application will take all these incoming intents and it will order them in whatever order it decides to. Actually, that's also what Web2 trading platforms do. That's what Coinbase does as well. Right? I have no idea how Coinbase chooses my trade over yours, right, at a given moment. But the nice thing about it is that it's all verifiable in the end. This is a smart contract now. So a total order or a blockchain becomes a smart contract on this platform. Okay, where the smart contract has a state, which is a set of intents, and then a sequencer, where you choose which is the next trade in the sequence, and then a state changer. You change the state, but you can say that change the state after every single trade, or you can change the state or verify, prove the state, claim the state every second, or depending on your application. For example, if you are a super popular trading platform and you have like 1 million trades per second, then you may not want to verify or to publish every single trade. You only group them in a batch and every second you can prove it. But you see, these are now internal decisions that each application has to choose, as opposed to being dictated by the blockchain. Okay? All you have to do is to make these claims. I make the claim that this second, this is my state, and these are all the trades that I put into this sequence, right? But everybody can see the intents as well, that yes, I actually, and then I can complain. If you don't take my trade, I can complain. I say, this was my trade. Look, I submitted my intent. You didn't include my trade in the block or in the sequence. Why? Right? So I can question you. Yeah, but now it's my turn, I guess, to ask you questions. Let me ask you a question. So can you tell us a bit in Spicenet flow, right? So how do you actually how can you stay on top of the different chains, right, without paying the cost of bridging, right? Because we spend so much time thinking of that. Bridging seems so natural, but comes with a huge price in cost and time and everything. So you would have to keep records, right, of deposits on different chains, and all these records happen off chain, if I understand correctly.
The records actually happen on chain. So on our layer one, we can basically, like, it's an accounting ledger that basically says, like, you supplied us with USDC on base chain, but it doesn't really matter where you supplied it. It's like an accounting ledger that just says, like, you now own this much USDC and it's executable anywhere on any of the chains that we're sitting on.
So you have a unified view on your chain of your USDC on the different chains.
That's correct.
Connected.
Like, yeah, you'll have like a unified margin account, and you can use that margin on any of the chains that we're on, and you can even with specific Spice Edge integrations, which is something we're announcing in the next month here. Basically use your positions on certain venues as collateral across different chains and different venues. So, like,
I see. So I can have collateral on Ethereum and make a loan on Base, basically.
Exactly. Yeah, and not yeah, exactly. Well, not necessarily alone, but yeah, you get the point, I think. And like, use, like, your LP position on, like, Uniswap as collateral to collateralize, like, options or futures trading somewhere else. Yeah, all of that will be an option through our unified margin account as well.
Yeah, very nice, very nice. Of course, we'll have to dive into this to see all the details, to understand all the details of the integration.
Yeah.
But looking forward to getting proofs from all this.
Yeah, definitely. Well said. Yeah, maybe I'll let you tell everyone in our community what they can do to stay in touch with you guys, what you guys have upcoming that you want to direct their attention to. Anything else you think they should know before we do have to say bye for today?
Thank you for that, Matt. The simplest thing to do right now to get a feel, or feel for the thrill of instant finality, let's say, is to go to fastset.xyz and play with our network. Play with there is a demo wallet. I think it's called wallet.fastset.xyz, and you can make some transfers, and you can be part of the TPS. You can see the TPS right now. I think it reached 140,000 TPS on the current public network. We have an internal network that will announce soon. We are going to announce our DevNet very soon, and on the DevNet we reached 250,000 TPS, but that's not public yet. It will be very soon. But again, this is not a limit. It's just the beginning. There is no limit in terms of the TPS because of the embarrassing parallelism. But for everybody who wants to play with our network to see what it means to have a set instead of a chain of transactions, go and try it at FastSet XYZ. And if you have any ideas how to connect this with your projects, we'll be very glad to have a conversation.
Yeah. Awesome. Well, thank you guys so much for joining. It's been a pleasure to have both of you on Spicy Takes. Stephen, so nice to talk to you again. Grigore, so nice to be able to meet you. And yeah, my God, I'm super excited to continue to dive
Me
into
too.
this.
And I'm so sorry for the technical difficulties.
No, I mean, I love it. I mean, I could spend hours nerding out with you. So it's exciting to be able to kind of sit back and listen and soak in knowledge, as Stephen was saying before.
Yeah, thanks for having me as well. Appreciate it. Great to be here with you guys.
Thank you.
Awesome. Well, until next time, guys, stay spicy, and we'll see you next week.
All right. Bye, everybody.
Bye-bye, everybody.